Hi, I'm Aidan Ruff and I'd like to talk to you now about my solar energy harvesting project. My wife and I bought a large farm in Aragon in Spain, up in the wilds in the mountains, where we're far away from people and unfortunately main services. So we're going to be getting our water from a borehole and our power from solar panels. However, I have this idea that I'd like to run the house completely from solar energy, perhaps a bit of wind mixed into it as well. But that means I'm going to need a lot of solar power. I'm going to be having solar heating, solar air conditioning, solar hot water, solar power for my electric car. I've got a Tesla Model X which needs a lot of power. We're going to have swimming pool pumps and all the other stuff that goes with it. Telephone, lighting, all the kind of things that we need. Fortunately, we've got some fabulous internet. We've got long-range WiMAX internet, which gives us about 30 meg on a sort of a long-range focused wireless system. So that's probably one of the most essential parts of life out there. So how am I going to do this? Well, I've done some tests and I figured that with around about 15 kilowatts of solar panels, about 80 kilowatt hours of batteries, we should pretty much get by. However, in the winter, obviously when the weather's poorer, we're going to have some issues, especially with the heating. So I realized that to optimize the amount of power, what I needed was to actually track the sun with the solar panels. So I've designed a system which is a 2-axis tracking system, which you can see the prototype here behind me. The idea being it'll track in azimuth, so across the sky, it'll track in elevation up and down. Now there are some systems around which just use an optical sort of thing to measure what the intensity of the sun is, and then it'll try and track the panel accordingly. But these use fairly complex optical arrays and they don't always get it right. So I realized there's a very simple way to do this. Up in the sky we've got a GPS satellite constellation, and for a very small amount of money we can buy satellite receivers. So I've designed a circuit around the ESP8266, which is a fabulous little single on-chip computer with Wi-Fi interface. This drives a motor speed controller which runs 2 linear actuators, one of which tracks across the sky and one of which tracks the panels vertically in elevation. So with the GPS receiver, I know exactly where on the planet the solar panel is located. I know what the time is, Greenwich Mean Time, because it all comes down from the satellite. And from those 2 bits of information, I can then calculate where the sun should be in the sky, what time is sunrise, what time is sunset. I didn't want loads of wires going to this thing, so what I've done is I've made a little circuit board which goes on the back of the tracking controller, which I plug the solar panel into, one of them anyway, the 24 panels, goes into the box and out of the box. It taps a little bit of power, just a watt or two, and it charges some lithium-ion batteries. And then I use those 2 batteries to convert the power to 12 volts to run the motors and 3.3 volts for the main electronics. So this system put together in a little box sits on the back of the panel. 3 panels hooked in series give me around about 90 volts. And then I'm feeding that power into an MPP solar PIP4048 solar charger inverter system. These are great little units. They're 4 kilowatts each. They'll take 3 kilowatts of solar panels. And what will happen is they'll give you 4 kilowatts of RMS power, true power, and up to 8 kilowatts for about half an hour. What's great about these is you can connect them in parallel up to 6 units. That'll give me 24 kilowatts of power, up to 48 kilowatts for a short period of time. Not that I imagine actually ever needing that. And each of these units has an RS-232 serial interface on it, which can give you all sorts of information as how much power is being generated, how much power is being used, what the battery voltage and current, etc., all these sorts of things is. So I've built another unit which actually talks to this, and it also coincidentally talks to another little circuit board which I can then plug into each array. So each of these circuit boards will read the current coming out of up to 8 of these 3-way solar arrays. And I'm going to have around about 15 kilowatts of these things, 60 panels or 15 arrays, all tracking across the sky and following the sun. And the purpose of the little 8-way unit is to allow me to monitor the power coming off each of these 3-way arrays. Because if one of these packs in, I'm not going to know about it really. I might notice the power's dropping a bit in the winter, but I'd like to know before it actually becomes a problem. So I can monitor the output of each of these, and then Another project that I've done with a friend of mine, Pete Scargill, is around the ESP8266, is mains control. And we've created a setup script for a Raspberry Pi computer, or any other cheap Linux computer, which installs all sorts of clever software, including a thing called an MQTT server. Now, my little power monitor board talks to the MQTT server over the internet using what are effectively text messages. So I can send messages saying solar panel 3 is generating 800 watts, for example. And if all my solar panels are generating roughly 800 watts, then all the garden's lovely. However, if one's only generating 100 watts and the other one's generating 800 watts, I want to know about it. Now, it could just be some grass has grown up in front of the panel, or they've gotten dirty, or something like that. Whatever, I can go out and I can fix that before it becomes an issue. So that's the basic crux of the project. We've got a solar tracking system, we've got a solar power monitoring system, and we've got the ability to send it to a remote server. And once it gets to a remote server, I can pretty much do anything I want with it using a very clever program called Node-RED, which comes from IBM. And Pete and I have been working on and off with IBM engineers to develop this and create something which is actually really useful and usable. And that's, if you want to have a look at it, you can look on our blog, which is www.esp-go.com. And on there you'll find the last 5 years worth of conversations with hundreds of engineers around the world and hobbyists like myself as we've drawn all this kind of stuff. And it's all been distilled down into this project. I hope you find it of interest.